Hi, this is Mr. West, and today we're doing a tutorial video on factoring expressions. This, of course, is from Math-DrIlls.com. Make sure to check out Math-DrIlls. They have amazing math resources. So to start with this, I really want to introduce the distributive property first if you haven't heard of it. So if you look here inside this expression that I have written, x plus 5, there's nothing we can do. They don't have like terms. They have the same variable with same degree. And this is a constant, which is just a number, and that cannot be combined with an x. So there's nothing to do inside the parentheses. But there's a number outside the parentheses. There's implied multiplication. And what we can do to simplify this expression is to distribute. And that means we're going to take turns multiplying the 3 times the x and then 3 times the 5. And this is how we can rewrite it. 3 times x plus 3 times 5. It's equivalent. That means it's the same value. So if we're going to simplify this further, it would be 3x plus 15. Why is that important for factoring expressions? Well, factoring is going in reverse. So instead of distributing, which is make it into an expression without parentheses, we are going to be factoring, which means we're going to go from this into a parentheses form, which is called factored form. And there's really 3 steps for doing this. So number 1, we're going to find the GCF. That means the greatest common factor. So we're going to look for a common factor between all the terms in the expression. Number 2, we're going to put that factor outside the parentheses. And then step 3 is we're going to divide the inside of the parentheses, the remaining expression, by the GCF. It seems more complicated than it actually is. Let me show you how this works. So this should look familiar, 3x plus 15. That's the example we just did with distribution. So if we're looking between 3x and 15, we are going to find the GCF. You're like, well, how do I find a GCF with an x? We're going to ignore the x. You're just going to think about the coefficients of any of the variables and the constants. So what are the greatest common factor between 3 and 15? Well, that's 3. 3 goes into 3 and 3 goes into 15. The other factors of 15 are 1, 3, 5, 15, but obviously 5 doesn't work. 1 is not relevant because you can always factor out a 1, and 15 is not good either. So 3 is our only choice here. So we're going to put the 3 outside parentheses, and then we have something left inside the parentheses. Well, this is where we divide the term by the GCF. So we're going to divide this by 3. So 3x divided by 3 is just 1x, and then we're going to divide the 15 divided by 3, and that equals 5. So I'm going to put plus 5. You'll notice I just copy down the plus sign. It gets a little tricky when we have some negatives in there, but for right now, most of the time, we're just going to copy down that middle term. So what's left is we have 3 times quantity, 1x plus 5. Really, that's 3 times x plus 5. And I think that's where we started. It is. So that is our correct answer right there. Let me highlight it in yellow just to show that that's what we got for the correct answer. Okay, moving on. So if we look at we might as well go to number 2. Number 2. So this one looks a little bit more difficult, right? We have some bigger numbers here, but we still are going to look for the GCF. So 1, let me just copy and paste this. So I copy this. I don't think I got the S in there, but I think we get the point. I missed the S. So let me go back actually. So step 1 is we're going to find the GCF. So if I'm looking at my GCF for 8 and 72, I'm going to teach you a trick that will help you do this a little bit more simply. So the first thing we should always do is we should try to see if we have 2 numbers, so we have 8 and 72, we should always try to see if this smaller number is a factor of that bigger number. Is 8 a factor of 72? Because that will always be the GCF if that's the case. And this is true. 8 is a factor of 72. 9 times 8 gives me 72. So I know 8's a factor, so that is going to be my GCF. Anytime you can get that coefficient or whatever the smaller number is to be a factor of the other one, it makes it way easier. So I'm going to put the 8. I'm going to put outside the parentheses. So I'm done with step 1, done with step 2. Okay, I'm on to step 3. So now I'm going to do 8y divided by my GCF, which is 8. And that just gives me 1y. Or I could just write y. I want you guys to get comfortable just understanding that that is 1y. I'm going to copy down that minus. So I'm going to put y minus, and then I do 72 divided by 8, and that gives me 9. Now, another way I like to do this, so this is my correct answer. Let me highlight it real quick. So another way I like to do this is once I get my GCF out in front, so in this case 8, I like to just think of myself 8 times what gives me 8y. So I'm looking over here now. So 8 times what gives me 8y. That's the way I personally like to do it. And I'm thinking, okay, well, 8 times y gives me 8y. And then I think to myself, 8 times what gives me 72? And I'm looking over here now. So 8 times what gives me 72? And I think, okay, 8 times 9 gives me 72. So it's the same thing I just did with division, but it's just a different way to think of it, making it into a multiplication. And I have found that students like that. Let's move on to number 3. This one's the easier one. So we see that we have 9 and 18. I think you're figuring this out. The smaller number is 9. That is a factor of 18. So I'm put 9 out in front, and then I put parentheses. And I say 9 times what gives me 9a? Obviously just a. And then 9 times what gives me 18? And that's 2. 9 times 2 gives me 18. So I'm going to put 2, and then I just copied on that plus sign, and I'm done. That's all there is to factoring. It's just backwards distributive property. Let's try to find a different one, maybe one that doesn't have the smaller number as a like term of the bigger number, and I'm not seeing any. So I think this one, you can use the smaller number each time as the greatest common factor. This one has where they have the same value. So they are the same, right? So if they're the same, I can just factor out the 8. You know that 8 is going to be a factor of 8. And then inside I have c. 8 times c gives me 8. And then 8 times what gives me 8? That's 1. And then I copy down the minus just like that. Let's do a few more, maybe some bigger numbers. How about 27? So 27, I'm going to factor out a 7 because 7 is a factor of 7 and 28. I'll put parentheses down. 7 times what gives me 7z? Well, just z. 7 times z gives me 7z. And then 7 times what gives me 28? Well, 7 times 4. And then I just copy down that minus sign. And I'm done with that one also. Let's look for a few more. Maybe, what about this one? 21. So 21, we have 3x and 24. Copy down the 3. 3 is a factor of 3, and 3 is a factor of 24. So I'm going to put an 8 here. 3 times 8 gives me 24. I'm going to copy down the plus sign, and then I can write the x right there, and I'm done. Now, there's a way to check your answer. Probably should have mentioned this earlier, and we can just distribute to see if we did this correctly. So 3 times x gives me 3x. 3 times 8 gives me 24. Put the plus sign, and yes, I have checked my answer. One thing that's important about this is you got to understand your multiplication table. So if you don't know your factors, that is going to be a challenge for this entire worksheet and for this topic. Let's do one more. Number 14, we'll end on this one. So 6 is a factor of 6 and a 48, so I'm going to factor out the 6. 6 times a is going to give me 6a, copy down the minus, and then 8 is going to be my factor of 48 multiplied by 6. That gives me 48, and I'm done. That's all there is to it. If you have any questions, make sure to leave a comment below, and I look forward to seeing you next time right here on Wes Explains Best.